So this question involves a shape that they want to find the area of, and basically we've got to look at the information they've been given. So we've got some lengths and angles, so it looks like we need to be using some form of the trigonometry ratios or any triangle ratios, sine rule, cosine rule. And we can see in here that we don't have a right angle, so we're not going to be using the trigonometric ratio, sine, cosine, tangent. So it looks like we're going to be using either sine rule, cosine rule, or a combination of both, of course. Because the question wants the area, then at the front of our exam paper we know there's a formula that says the area of a triangle could be found by doing a half AB sine of C, where the triangle could be A, B and C. So the angle would be at C, the little length of A would be there, the little length of B is opposite the vertex B. It's a side angle side triangle, and that looks like the formula that we'd like to use because this is about working out area, and it looks like I could break this shape up into triangles. They're telling me that the DB length is 240, so of course I can add that onto the picture, and 240. Then I can see straight away we do have two triangles. So it'd be useful to work out the area of both of them, add them together, get the total area. This is the formula we want to use. So we need a side angle side triangle. So we've got a side, it would be nice to get this angle here. Then we've got our side angle side triangle to work out the area of that top one. Well, what we can see is we do have a length and an opposite angle, and we do have a length, and we could find this angle here. So when we've got lengths and opposite angles in a triangle, it's telling us to use the sine rule. Now, because we want an angle, then we write the angle part of the sine rule on top. So the sine of big A is over little a is equal to the sine of big B over little b is equal to the sine of big C over little c. Now, you don't have to use the letters A, B, C. It's all about sides and opposite angles. So when we want this angle here, we're going to do the sine of that angle over 68. So we're going to be writing down the sine of the angle we're trying to find, which is, I'm just going to call it x. So the sine of x is over the length of 68 must equal the sine of 85 degrees, because we're going to use this opposite angle here, and length over 240. And because we want the x, then we're going to be writing x equals the sine of 85 degrees over 240 times 68, and because we want the inverse of sine to get the x value, then this is all going to be sine to the minus 1. So on our calculators then we can type in second function, the sin button, that gives us the sine minus 1, bracket, we want to do the sine of 85 divide by 240 times by 68 close bracket equals. So we get an answer of 16.395. So 16.395. Don't round your answers too much at this stage because these are intermediate numbers. So that angle is 16.395 degrees. And of course the opposite angle can be found now because angles in a triangle add up to 180. So if I add on 85, take it away from 180, ignore the negative sign, 78.605. So this angle here, 78.605 degrees. Well, that then helps us to find the area of that triangle, because we now have a side angle and an opposite side. So side angle side. So I can find the area of that triangle. What we need to do for this triangle, of course, is we've got a side, we've got the angle here, and we've got a side, because the angle here must be 136, take away that. So 136 take away 16.395 equals 119.605. So this bit here is going to be 119.605 degrees. So we've now got two side angle side triangles where we know the side, the angle, the side. We know the side, the angle, the side. So we can work out each area by using the half ABC sine formula. And so triangle ABD is going to be equal to a half times the length of 68 times the length of 240 times the sine of 78.605 degrees, and the area of triangle DBC. So triangle DBC is going to equal, so triangle DBC is going to be a half times 95 times 240 times the sine of the angle between the two lengths, sine angle sine, so 119.605. So we're going to work out each of those. So the usual thing, get the calculator. So we're going to be doing a half times 68 times 240 times the sine of 78.605 equals. So, whoops, press that twice. So let's do that again. So 0.5 times 68 times 240 times the sine of 78.605 equals. Alright, so 7999.15, and the other one 0.5 times 95 times 240 times the sine of 119.605. So 9911.75. The total area means we've got to add those together. So we've worked out what those two are. Those are the two answers for the areas of both triangles. So we're going to add those together to get the total. So we've got 9911.75 plus 7999.15 equals, so 17910.9. As always, we look at the question again, make sure we've done what they expected. So it said work out the area of the field. Yeah, we think we've done that. And we give the answer to 3 significant figures. So again, we always look for the accuracy they want, and they want 3 significant figures in this case. If they don't give an accuracy, then do 3 significant figures as a standard. Find the first non-zero digit, 1, second one, third one. So it's asking us to round to the nearest 100. So it's with 1900. So 17,900. Sorry, 17,900. Okay, so the first significant figure, the second one, the third one. It's in the hundreds column. So round to the nearest 100.